Dear students, welcome to another lecture in industrial engineering. Yesterday we were seeing about the process engineering. So as part of process engineering, today let us start with this topic, preliminary part print analysis. Now after the product is designed by the product designer or product engineer, you can say, otherwise design engineer, the subsequent discussions with the process engineer and the actual data represented by the part drawings or blueprints or part prints, this is carried out. You see, in the olden days, before the Xerox machines and other things came, they used to photocopy with the help of ammonia prints. In those days, these ammonia prints used to come blue in color. That's why it was called a blueprint. Nowadays, nobody adopts blueprints, uses blueprints. Mostly we use CAD drawings, printouts on big plotting machines, plotters. Okay, so once this design engineer has designed the product, now you know the design engineer and this process engineer, these two people should sit together and they will look at these things, the part drawings or the printouts or the plots that are printed. Okay, the process engineer, he must study the part print and understand the requirements in the final product and decide how to use this information that is available in the part print to get the required product. You see, when the part print is prepared by a product designer, okay, see, he has designed the product and also he has made prints and given. Now the responsibility of this process engineer is to make that part. So in making that, first he will read the part drawings. Okay, and now when we said here, we are not saying reading the part print. We are saying part print. We are saying about the analysis of the part print. Now here there is a definition given about the part print analysis. See, the detailed study of part drawings for manufacturing of the part, that is called as the part print analysis. You see, now in the next figure we see we can say a CAD drawing. Okay, here you see there is a worm. Worm and worm wheel are there. So this is a pair of gears. Okay, see, this is the pictorial representation and that is shown in the orthographic projection like this. So this is how a part print is given to the process engineer. Now the process engineer will look at it. He will see how the things are, what is the maximum diameter. You see here the maximum diameter, you can see 47. Okay, and the total length of this part is 240 and the tolerances are also given, minus 0.5, here minus 0.1. okay, on the positive side they have not given. Some of the things they have given plus minus also. See here, this is 92 plus minus 0.02, like that. Okay, so now here this should be machined and this worm should be made, and also there are slots also on either side. Okay, and then different things are there. Actually, you can see which they are talking about the datum A, they are talking about the datum B, and how other things are, and also here the title is given. Title of this drawing is, it's a worm. It's called worm. Okay, the scale is 1:1. Sometimes scale may be 1.1, 1:2, 1:10, like that. That should be properly read. Otherwise instead of making the to the right dimensions, you may end up making it half or something. But you see that such a big mistake nobody will do, should not do. Okay, see here the sheet numbers are given here, the revision history. You see here revision 1, date on which this is plotted, who is the author, and what is the description, what is the company. See, and here the title is worm, the scale is given, sheet number is given, drawing number is given here, gross weight. Anyway, though it is left blank, weight also can be given, so that we will know finally what will be the weight, and what gross weight and finished weight. Okay, all these things even the other things also are given, like this center distance, module, number of starts, pitch diameter, and all these things. All this, see, this is one example. You see, example of a part print. Okay, now in the part print analysis, the process engineer, he seeks to determine the following things. What is the general description of the part? What is the general configuration of the part? What is the material from which the part is made? What are the basic manufacturing processes? What is the basic manufacturing process? Then what are the design modifications which they should request? Because why there is a revision 1, revision 2 and other things are given, because you see, you may request those people, design engineer, you see, this is something I want you to change, because such a thing we cannot in our shop floor with our existing machine we cannot do it, or something like that. Or if you make to these dimensions, this problem will come, that we can tell. Okay, now next okay, we have seen this. Now see, I didn't describe about all these things, because now we are going to discuss about this in detail. Now first, when you see a part print, you should know what is the general description of the part. You see, the general description of the part means the part description is learned from the title block on the print. You see, now this is the print. See, now from the title you came to know that this is the drawing of a worm. Okay, see, that is the general description. That general, from the title block on the print you will come to know. As there is limited space on the part print, the description may be abbreviated. Okay, if there is any ambiguity means it is something that is not clearly understood, then the process engineer should consult with a product designer for clarification. If anything he is not understanding, some problem, or the dimensions that are given are not matching up, or the surface finish that he is asking, whether we'll be able to produce it or not, all those things, some clarifications if necessary, the process engineer should ask the product designer, product engineer. Okay, other information important to the general description is the part number and the number of the subassembly or assembly of which it is part. You see, actually this may be only a small part, and this may be going into a subassembly, and these subassemblies may be fitting into a larger assembly. Okay, so what is the part number of this, what is the title of it, and all this general description, all these things first he will need to know. The second thing that the process engineer should know is the general configuration of the part. You see, when we are saying configuration, what are we meaning? It is the general size and the shape of the part. Okay, and then the workpiece, as the workpiece has to be moved from operation to operation, the process engineer is concerned with its weight also. You see, weight also is necessary, a necessary consideration, because it will be going from one machine to another machine, from one operation to another operation, so we need to carry it, and what is required to carry, how heavy it is, we should know. And then a part that is complex in shape may require several types of jigs and fixtures to clamp the part and perform operations. I don't know whether you know what are jigs and fixtures. Okay, till now you have not come across jigs and fixtures, then you will study hereafter, or you may have already studied, in production engineering and robotics or something. You may have come across what are jigs and fixtures. Okay, you see, if these fixtures are those tools which will be holding the job on the machine tools. Okay, jigs may be will be, what I'm saying is a brief description about these jigs and fixtures. Okay, jig may be smaller compared to fixture, and jig may be also used to guide the tool, like if you want to drill holes on a plate. See, jigs may locate where the hole is also, and it may guide the drill bit also, like that. See, so a part that is complex may require some jigs, fixtures for clamping the part to the table of the machine tool, and also to perform the operations. You see, that's why he should know how big it is, how long it is, what is the maximum diameter, what is the minimum diameter, and what will be the weight of it. All these things the process engineer should know, so that he can decide upon the types of jigs and fixtures that are required. Then tooling for small parts can be designed to be turned over or moved about by hand on a machine table. But for large parts, then you may have to use some conveyors or overhead cranes. Okay, such things you may need to use it. So the shape of the workpiece influence which of its surfaces must be machined first. You see, depending upon the shape, we will, the process engineer will decide which surface should be machined first, and what is the method of location of that machining, so that the maximum dimensional control over its geometry can be had. Okay, you can have the maximum dimensional control. Okay, so you see, that is why we are studying about the general configuration. Size matters and the shape matters. So depending upon that, we fix jigs and fixtures, and how we are going to handle the part and all. Okay, the size of the workpiece influences its mobility and thus affects the rate of production. You see, if it is very difficult to handle, and from moving one place to another place itself it is taking time, that means you will not be able to produce many parts. So it affects the rate of production. Rate of production means what? Per hour, how many parts you are producing is called as rate of production. Okay, you see, suppose you are spending more time in handling the things, in clamping the parts, okay, and in deciding in fixing the jigs and other things. If you are taking more time, then the rate will drop. Okay, rate of production will reduce. It also affects, it means the size also affects the number of operations which can be combined at one setting of the workpiece. You see, some of the operations normally for saving of time and other things they combine. Okay, and see, depending upon the size, if the size is very big or something, you may not be able to combine many operations. Okay, the ease with which the workpiece can be handled probably has the more influence on production rate than any other single factor. You see, how many things you are able to produce in 1 hour, that is the production rate. That depends mainly upon this fact, that what is the ease of handling the workpiece. Are you able to handle it easily, or we have to spend more time and care should be given for handling it. Then the product, it affects the production rate. Okay, now see, now we were seeing these things: general description of the part, general configuration, then material from which the part is made, and basic manufacturing process and design modifications. We have seen the first two, the general description of the things from the title title block itself. You will come to know on the drawing. The general configuration is the shape and size of the part, the weight of the part and all these things you will know. Now the third thing that we need to know is what are the material specifications. In the part prints, the information regarding the material from which the part is made is mentioned. It will be given also. This part is made of mild steel, or this part is made of alloy steel or cast iron or aluminium or whatever material that we are going to use. Okay, that will be clearly specified on the drawing itself. See, different materials present different manufacturing problems. You see, machining on a mild steel part and machining on an aluminium part. These two are completely different things. You see, they have different materials have different manufacturing problems, and also different manufacturing costs also. Cost, the money that is required for producing it. You see, some of the things are hard to machine, some are easy to machine, some need simple cutting tools, some need very advanced cutting tools. You see, all those things should be it will be these are the things that you have to consider. So you see, it is necessary to know the material of the workpiece in order to cope with both of these important problems. What are those two important problems? One problem is the manufacturing difficulties or manufacturing problems, and the second is what will be the manufacturing cost. See, these two of the things are affected by the material. Okay, so the next thing that you should, as a process engineer, you should know is the basic manufacturing process. The basic manufacturing process, that determines the subsequent operations to be performed on the part. Okay, see, in some part print, only the material specification is presented. See, what is the material that is given, and the process engineer is left to determine whether whether the piece will be casted or forged or made from a bar stock. You see, sometimes this freedom will be given to the process engineer, but in most of the times they won't give that freedom. The design engineer will tell, see, this is the material that you have to do, and this is the manufacturing process that you have to adopt. That's all. See, no freedom. Whatever is mentioned, the process engineer has to do. Okay, so that's what here they are saying. In most of the cases, the decision is not left to the process engineer, but it is either spelled out with the material specifications or in the general notes. Okay, on the drawing itself they can tell, or the general notes that are attached to that drawing, there they may tell what is the basic manufacturing process. See, if only few parts are to be manufactured, see, the design engineer can come and talk with the process engineer and discuss. But if we are talking about parts which are the number of parts going to a big number, like 50 parts, 100 parts, 100 different parts that you have to manufacture. You see, you will not be able to talk each and everything personally. See, therefore all your decisions will be based upon that drawing that you are getting on the part print analysis. See, now we are talking about the part print analysis, and the another thing that you should gather information about is the design modification. You see, the revisions in the drawings are often made at the request of process engineer. You see, actually first he makes a drawing and gives, and he shows to the process engineer. Now process engineer says, oh, here we need you to change this, we need you to change that. Okay, see, these are the revisions. You see, then it will go back to the design. So it will go back to the design engineer, and he will ask his department people who are working on CAD drawings. Here you make this change, you make that change, okay, because the process engineer is asking you to change. Okay, you change and give. Okay, so, and when they give no, there you have to write this is revision 1, this is revision 2, or this is revision 3, or whatever. You have to write and give. You see, you should not simply orally just so, because that was okay, okay, you manufacture for this. If he says you should manufacture for 50 mm 50 mm diameter, with plus or minus 0.02 mm, and then this man may say, no, 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 plus or minus 0.2 is a very close tolerance. I will say, I will make it plus or minus 0.03 mm tolerance. See, oh, okay, see, the design engineer may agree, may not agree, because it will be affecting the quality of the product also. Okay, suppose he agrees, that should not be kept just orally, it should be put on the drawing. Okay, the reason for revision drawings may be to correct errors, to reduce costs, or to improve the manufacturing methods, to improve the existing design, or to facilitate inspection, to improve quality, and many others. See, these are some of the reasons why a process engineer is asking for revisions. Okay, any change in the design may have an effect on the operational sequence, on the tooling, on the locating system, or the overall manufacturing economy also. You see, all these things. So it is always um, see better to take the revision drawings and then work upon it. So when you get the part drawing like this, you see, you have to consider all these things. You have to determine the following things: general description of the part, general configuration of the part, that is the shape and size, how the shape and size is, say what is the material that you have to produce it from, and what is the basic manufacturing process, and what are the design modifications that you, as a process engineer, you are asking the product engineer to do. Okay, see, so after this, next we come to this topic: planning of processes from raw material to the finished product. See, we start with raw material and we go up to the finished product. What are the things that are involved? What are the steps? Okay, the steps in process planning. Planning of processes means process planning. Okay, process planning or process engineering. You see, we yesterday we saw that these two are the used for the same thing, same two. Alternatively, we can use these names like process planning and process engineering. Okay, so now what are the steps? There are a number of steps here. How many steps are there totally? Oh, here there is a diagram given here. You see the steps in process planning: 1, 2, 3, 4, 5, 6, 7, 8, 9 steps are there. You see, first one is part print analysis. This is the thing that we have seen. Then make or buy decision, select best manufacturing process, determine sequence of operations, combine the operations, then selection of machine tool and equipment, and inspection, miscellaneous functions, preparation of operation, and route sheets. You see, some of the things 4 are covered here in this slide, and the remaining are covered here. So let us go through it. See, the part print analysis we have seen just now. Process planning takes the input from the design department in the form of a drawing. You see, what you are getting is a drawing from the design department. Okay, and also other manufacturing specifications. You see, along with the drawing, they may give you a sheet also in which other specifications are mentioned or special notes are mentioned. These are the inputs. These inputs are properly studied, and this study we called it as part print analysis, and the part is listed and a part list made to determine the number of parts required in the final product. Okay, so this is what part print we have taken and we have done analysis for. Okay, now the second step in process planning is make or buy decision. You see, make means you make it, buy means you buy it. What are you making and what are you buying? You see, the part can be made in the factory or a part can be bought from outside. Okay, see when okay, so let us see what they are saying here. See, it is not feasible to manufacture all parts in the final assembly because some of parts are cheaply available and some are difficult or require more time. You see, some of the things no are easily available if you just go to the hardware shop and ask, yeah, you give me this number of bolt, they will give. You see, what is the point in sitting and making thing? There is no point. Okay, so such things should be bought. You should not be making those things cheaply. They are available, and some of the things are very difficult and require more time. Okay, because of which you see, it is better that you do not do it, but instead you outsource the thing. Ask someone else who is a specialist in that to do it. So a decision is to be made as to which parts are manufactured and which parts are purchased from outside, and the list is given to the purchasing department. Suppose if you want to purchase, so say suppose the design department has given you part drawings of some 100 things. Okay, out of which some of the things can be bought from outside. Okay, so you have decided whether to buy or whether to make. Okay, if you decided some of the things are to be bought, now whatever is to be bought, you have to make a list and you have to submit to the purchase department and ask them to procure this is the part that we want to procure from outside, and these are the number of parts that we want. Okay, then they will purchase and give you. Okay, so that is the second step in the process planning. The third step is selection of basic manufacturing process. See, once we have decided, you see, now bought means here itself full stop. But if you have to make, then we go to the third step. The third step is what is the basic manufacturing process. You see, once the decision to manufacture the part is made, then the next step is to determine which basic operations like casting, forging, etc. are to be performed on the product. You see, actually, from the mechanical perspective, if you are seeing, you will be able to understand. As a mechanical engineer, if I say casting, if I say forging, you will know. Okay, see, other engineers may not be able to know. You see, now we are studying all this with respect to the mechanical engineering industry viewpoint. Okay, so now what are the basic manufacturing process? Is it casting that we are doing, or is it forging, or is it some other thing like extrusion or something, or are you going to fabricate it or what? All those things. See, what is the basic manufacturing process that is involved, that you have to decide. This sometimes will be specified by the design engineer. The freedom may not be given to the process engineer to choose, but in case he has the freedom to choose, then he has to decide which of those basic manufacturing process your part is going to use. Okay, then the most suitable method from various methods is selected by comparing the cost and other factors. Suppose a part can be made in 3 different ways through three different processes. Then you have to you have to choose. You have to make a decision which process you are going to use. For that, you have to compare the cost also and other factors like ease in manufacturing and whether you can do it in the first place in your industry or not, and all those things you have to consider. So this is the third step, selection of basic manufacturing process. And the fourth step is to determine the sequence of operations. Sequence of operations is which first, which next. This is what you have to determine. Okay, next, the fifth one, combine the operations. Fifth step in process planning is combine the operations. As many operations as possible should be combined to reduce the production cycle. Operations can be combined by simulation and by integration. You see, we need to try to combine activities so that this cycle time the cycle time should be reduced for producing the part. Okay, then so simulation, you see they are saying you can do it by two different ways, simulation and by integration. Simulation involves those combinations where two or more operations are performed at the same time simultaneously, and whereas integration, several individual operations are combined in succession but not simultaneously in order to save setup times or loading and unloading. Okay, you see it can be more than one operations are being performed simultaneously. Okay, and it can be that once you have loaded means, you see, once you have fixed it on a vice, okay, there itself we are doing all operations now, changing from one place to another place and transporting again, fixing it there, and all those things you can avoid. See, thereby see, you are saving time, and thereby you are you are reducing the production cycle. Okay, so you can combine the operations by using any of these methods. Then the next step in process planning is selection of machine tools and equipments. See, depending on the quantity of the product, and the quality and the surface finish required, and the cost of a product, and the type of material, etc., the machines and tools are selected. See, first what we talked was the basic operation, basic manufacturing process, and afterwards, there will be subsequent operations that you have to do. For that, you have to choose machines. Okay, then the seventh step is the inspection. This step involves determining the stages of inspection, the tools that we are going to use, and the gauges that are required for this inspection. Okay, and at what stages you have to do. Stages of inspection means, is if the raw material, from the raw material to the finished good, if it is passing through 7 machines, you see at what stages the dimensions should be inspected for, now which tools we are going to use, which are the gauges you are going to use. You see, all those things you have to determine. Then some of the inspection tools are required to be designed. Suppose you are not having some of the tools, you may have to design it, and you have to issue orders to design it, and you should procure it. Okay, so this inspection also you have to consider. Inspection is the 7th step. Then the 8th step is the miscellaneous functions. Like miscellaneous function means other activities like labor requirements, and setting up time standards, estimating the cost of production. These are the miscellaneous functions. If the production cost is more than the expected cost, then the certain revisions in the above steps are necessary. You see, actually, you have some expected time, expected cost, you see, within so many rupees, it should be made. And when you're considering the production cost of your by adopting your method and your process, then if the cost is coming more, then there is need to be there should be revision made. Okay, so that the cost can be brought less than the expected cost. Okay, then the last step, or 9th step in the process planning, is the preparation of operation and route sheet. See, this is the sheet that you are going to make. This sheet contains the steps to be followed during manufacturing. The list, it lists the manufacturing operations in the decided sequence, the tools, the setup, the operation time, along with the machines associated with each operations. All those things now you have to consider. So these are the 9 steps in process planning. Now let us discuss the next topic, factors which affect the process planning. So here are certain factors we are going to see. One is the production methods, second is size and type of raw material, third is process capability, fourth is quantity to be manufactured, delivery dates, and surface finish and accuracy required. These are the 6 different factors that will be affecting the process planning. The production method, the process by which the product is made influences the process planning, because the processes are changing, then the other things change, like machines, tools, labors, and schedule, everything changes. Okay, so the production method affects. Okay, production. Suppose one person decides, I will cast this. Another person decides, no, I will machine the thing. Okay, see, different production methods. On the basis of that, your process planning will change. Okay. The second factor that affects is the size and type of raw material. You see, as we have seen before itself, you see the size and size matters, because material handling and other things you'll have to do. You have to see here, the types of fixtures used, the coolant used, the cutting tools used. Okay, you see, these are the things, they vary from material to material and from different sizes of the same material also. And the size and type of the material determines as to which basic method of manufacturing process should be used. And the component, here it's an example given. You see, connecting rods are to be produced, so you have to either adapt a casting process or a forging process. You see, like that, see, the size and the type of raw material also affects your process planning. And the third factor which is affecting the process planning is the process capability. Capability means, in your company, in your factory, or in your machine shop, what is your capability to produce, and how many machines you are having, and to what tolerances those machines can produce, with what accuracy they can produce. Suppose your process capability, see, the tolerances cannot be achieved on your machines, because your machines are old, and they have so much play and other things, then you cannot have close tolerances there. Okay, so then you say your process capability is not there. Okay, then you have to you have to look to other things. Okay, then the knowledge of process capability of the machines enables the process engineer to compare it with the design tolerance, thereby make the right selection. You see, suppose if he is having 2-3 machines, and different machines have different process capabilities, that means within the what tolerances they can produce. You see, depending upon all that, you see, if you have different machines and the process capability, then you will be able to choose for the given design tolerances which machines should be used. Then next is quantity to be manufactured. How many things you want to manufacture? You see, higher the quantity, the more refined and more economical the process needs to be. You see, suppose you have to produce only few, 5 parts, 10 parts, that means, you see, you will not be, you will not be making a detailed process planning for that. Okay, whereas you have to produce 100 parts, 1,000 parts, then no, you see, depending upon the quantity, your process will become refined, and also it will become more economical. Refined means, small details also you will look into. Okay, see, mass production generally demands special purpose machines, and medium or job production requires general purpose machines. You see, there are different types of productions. You see, like job production is one type of production. Okay, then mass production is another. You see, like batch production is another. Like that, you have different types of productions. Job production means only one part you are producing, like you are producing an aeroplane. You see, only one aeroplane you will be making at a time. So okay, if you are making a big ship, which can contain the whole of Jalgaon. Okay, see, such a big ship if you make. um, okay, you see, some of the ships, they are very big, like they are traveling means, it will be like a small town traveling. Okay, like that. So such are job productions, that. So whether it is job production or batch production or mass production, it affects the process planning. Then the delivery dates of the products. You see, some people, some of your customer may be willing to wait for longer delivery date. Then you will have sufficient time as a process engineer to plan every aspect of the process in detail, and you can deliver. Suppose he wants urgently, very urgently, there is no time. Then what do you have to do? You have to put the schedule in such a way, that you have to put in more workers, or you have to ask them to work overtime, and some of the parts you may have to purchase from outside because you don't have time to produce. Okay, like that, those things also affect the process planning. And another factor that affects is the surface finish and the accuracy needed. You see, suppose you know see every tool, different tools, can give you different surface finish. Okay, say some you may have high speed steel HSS bits, or you may have carbide tips, say, or you may have any other tool, depending upon that the surface finish varies. And also machine, different machines may give you different surface finish, and different manufacturing processes may give you different surface finish. So for smooth surface finish, super finishing operations are also required. These are super finishing operations are after the manufacturing process. You have to go for super finishing operations. Say for that, you may need to require special purpose machines, also special machines designed to perform this super finishing operation also. Okay, and that if you want such kind of finish, you have to spend more time, and more time you're spending, and you're giving such a high surface finish, then the customer also will have to shell out more money. Okay, then the close tolerances require new and precision machines like CNCs, and they need highly skilled operators. Okay, so depending upon that also, our process planning will be affected. Okay, so that's all, friends. Today we'll stop here, and we will continue in the next lecture. Thank you.